Here we can evaluate an argument with a truth table. The argument goes like this. If you take a lot of math classes, you will lose sleep. You are taking a lot of math classes, therefore you will lose sleep. To evaluate this with a truth table, we need to write it in symbolic form first. So we need to describe what the premises are and what the conclusion is. The premises are everything before the word therefore. That's an easy way to note it. So it's the first two sentences. To write these premises in symbolic form, we need to define pieces. So let's call you take a lot of math classes P. Let's call you lose sleep Q, and go from there. So the first premise says if P, then Q. The second premise says you are taking a lot of math classes, which is simply P. The conclusion is, therefore, Q. So the argument in full form looks something like this. We take our premises, the first one, and the second one implies the conclusion. So remember, this is the form of an argument where in brackets we put all of the premises separated by and then these premises all together imply the conclusion. To evaluate whether this argument is valid or not, we'll go to the truth table. So we draw a truth table for that argument. Notice that we need columns for each of those pieces, and we'll build up to this final argument. So first, we have P and Q. We'll build the column for P implies Q, which is true except in the case where P is true and Q is false, which is that second row. True otherwise. Then P implies Q and P is the first and third columns combined with and, so it's true when both are true and false otherwise. Finally, we take what we just built and use that as the condition on a conditional statement. So for this last column, the only way this will be false is if this column before it is true and Q is false. But notice that never happens, because the only time that the premises are all true, Q is also true. So it's true there, and then also true otherwise. So because that argument is a tautology, meaning it's true always, this is a valid argument. And this argument is an example of direct reasoning. Direct reasoning, P implies Q, and P, therefore Q. So it's a pretty straightforward argument, and it's a valid one, which we've proven by building this truth table.